everything on. We have sounds. We have music. We have shot. Looks like we have shot. Welcome everyone. First of all, Merry Christmas. I hope you guys had some nice holidays. Good evening, good morning, good afternoon, good whatever for you guys. How is everyone doing? Pretty sure everyone is happy with the Christmas stuff and now the new year coming. So I hope everything is fine. I hope you guys had a great night, an awesome day yesterday with your families. So I know I had. It was fun. Kids playing with the new toys and whatsoever. Bigger kids playing with the newer toys. It's always fun. So here we are again, getting ready to start another stream on the Milo. So if you are new here, I've been doing some streams about the Milo CNC machine. I'm a CNC operator and I made my own CNC machines, a VMC, a CNC router, two versions of it actually. I do 3D printers, which are also CNC machines, just different type. So since I made a CNC router in the past and actually a VMC, VMC stands for Vertical Milling Center, big ass one, cast parts whatsoever. I decided to, for my community, to make a 3D Milo, a Milo v1.5 CNC machine. So I always said since the design first released that I considered the machine to add some stuff that I don't agree, like mainly the lead screws. I think it's absolutely a no-go. So yeah, and other design flaws that I consider that can be better made. So yeah, so the idea is I'm making the Milo but with my twist. Hey Joseph! Yeah, I'm good. As I was saying, we can do better. The idea is to make the machine as stock as possible, but with the design changes. So I don't agree with some 3D parts, 3D printed parts. So I'm gonna mill them myself. Maybe we'll provide a kit after we finish the machine and see everything is working and whatsoever. There's a high possibility to provide a kit for anyone who wants. So the main goal would be change the lead screws to ball screws, and that's the main modification, and make the machine as rigid as possible. For that I'm gonna fill everything I can with epoxy granite. When I say epoxy granite, it's epoxy resin mixed with some quartz sand. There are several grain of the sand. We won't use big stuff on this machine because the holes are all very small, but the idea is needs to be something everyone can get, and I'm pretty sure everyone can get some sand some bags of sand from a filter pool of the filtration system of a pool. So that's exactly what we need. It's based on quartz and it's clean. So worst case scenario, you only need to dry it. Just put it in a oven by batch and heat it to 100 degrees for a few hours and it's dry. So that's the idea. And so what's the point of this? The point of this is increase mass, and the resin, it's an excellent vibration dampener. So both together are great. Many high-end brands use this process for casting the whole structure of their machines. So yeah, it's something that's proven. I made it myself on my machine. So yeah, that's it. And do some other stuff, minor stuff. Like I'm not gonna use the regular ohm switches they use, which are just switches. I'm gonna go for optic switches. Well, not switches, but an optic system which works optically by the name, of course. What more? I want to take a look at way covers, because I don't like the idea of ships going on axis rails or ball screws. So when I start making these, when I decided to make this machine, I was just thinking of making using just regular ball screws with just one nut, no anti-backlash system, because ball screws have way less backlash compared to lead screws. But since the ball screws are cheap for this machine, and of course we are using the cheapest ones we can find, because the idea is also keep the price low, and we have the space, barely, but we have the space for the using double nuts. We are going with double nuts, so one nut is fixed, the other one it's preloaded, so that way the threads are always under load, and therefore there's no backlash. Of course, we'll increase the friction, or the wear, let's call it the wear, of the lead screws, of the ball screws, but we are not going crazy with high tension on or high load on the ball screws, so it should be fine for this kind of machine. Let's be honest, it's already overkill doing the ball screws. Well, not ball screws, I don't think it's overkill, but it's way overkill to go with double nuts. But yeah, let's have fun, that's the point. What more? Yeah, I think that covers pretty much it. So I've been working on a function model, just a simplified model of the machine, where all the dimensions are precise, but just not all the fancy parts with all the details and whatsoever. No need for that. We just need to keep it, to have the machine moving with joints and whatsoever, so we can simulate the movement of the machine and see if there's any collisions or whatsoever. make sure everything proper works before we commit to the build. As I said, I'm gonna do a lot of milled parts. Aluminum, it's not that expensive, but it's not cheap either, so let's not waste it. And machining time, it's also another stuff. So yeah, that's what we've been doing, and that's what we're gonna continue today. So I'm gonna go here, Fusion, which I already have opened. Let me go to the project, Milo. Okay, so I did a little work off stream, nothing too crazy, because it occurred to me how so on the last day we finished we finished the X and Y axis. I mean, for the ball screws. Not finished. We still need to do some aesthetics on the parts, but that's not important. What is important is the shape of them, and the whole point was to rush everything until we had the final dimensions of the ball screws, so I could order them. And I need to move a little bit. Oh, it's to the other way. Come on, just a little bit. Yeah, doesn't want to. Anyway, so as I was saying, the idea was to get the ball screws dimensions figured out so I could order them, or at least start talking to suppliers, because they have to be custom machined and whatsoever. So I actually did reach some suppliers, and actually I ordered a set already. I'm probably gonna order another set from another supplier just to check, to compare the quality. They are roughly the same price. So they asked me about $220 for the full package, and I mean the 3 sets of FF10 and FK10 bearing blocks with angular contact bearings, which cost about $25 to $30 a set, which is super cheap if you ask me. With angular contact bearings again, which increases the price substantially. And the ball screws, the 3 ball screws with 2 nuts each, all machined, everything ready to go, even the nuts machined. So yeah, I think it's a very good price. Let's see about customs. Custom fees, I have no idea yet, but I have to bring it out to get one first to check, but it should be fine, even if I need to pay something else, because we are talking about the everything ready to mount. So I think it's a good price. It's about, if we divide it, it's about $70 for each axis complete, which is awesome. And again, we are talking with double nuts and bearing blocks with good bearings. It's not the cheap deep groove radial bearings, so it's angular contact. So yeah, I'm happy with that. I'm happy with that price. Let's see how it goes. and shipping included as well. So it's not properly light stuff. It should be about 5 kilos of stuff, which is about 10 pounds, 10, 11 pounds, I believe. So yeah. Okay, so last stream we finished so we had the y-axis, which is this one, already done. We finished the x-axis, and we were working on the z-axis, and on the z-axis we were having some problems. Let me update the model. So okay, everything is updated. So I was having we were having problems for because of the guys who designed this didn't decided not to put these holes. These holes are the, hey Rodolfo, these holes are the ones holding the nut. So it's the holes there where we gonna attach the part that will have the nut inserted. So we were having problems that let me hide this guy. I could press V, but I'm gonna, yeah, Z plate, it's here. Okay, so this the problem was, since the holes were too close to these carriages for our double nut system, it wasn't ideal, because this thing, the nuts were crashing on the cars, which is no bueno. So what I did, I actually did offset the mount. So what I did off stream was I pulled down as further as I could the ball screw, so against the frame, which was like something 2 millimeters, something like 2 millimeters in relation of what it was before. So I could gain this space here for this step. So with this space, it's not very much, but it's enough. So I managed to gain, we have 4.7 millimeters. It's enough. For threads, ideally I would do another screw. I would put another screw to hold it with 3 screws, but probably here more in the middle. But that would require to modify the Z-plate, and I'm okay with modifying the Z-plate as long as it's easy. Here the problem is, so we're gonna need to modify the other plate already, but the modification is just adding two holes and 2 threads, which everyone can do. Like, it's just, it needs to be fairly accurate, but not stupid accurately. So everyone has either a power drill or even a bench drill, which is best. So they just need to accurately mark it, drill it, and tap it with M5 screws. Not a big deal. But here we would need to also counterbore it. It's not the end of the world as well. You can buy a counterbore tool and it's a tool which has a pilot on it, so it doesn't move as long as you do an accurate drill on the a pilot drill. Then it's just making a counterbore with it. But yeah, that requires buying a counterbore tool and whatsoever. I may do it optional if you really want to do it, but I don't see there's no absolute need. But yeah, maybe I can do that optional if you're willing to. It's just because of that. But the 2 screws will be just fine. With 2 screws it will be just fine, because all the forces are dealt with these guys in here, and this is just to make it go up and down. 2 screws will be enough, 3 screws will be better, so it's optional. And yeah, so what I did was just not this one. It was just to do an offset in order we have space. We are not going to use the top 2 screws in here. We're just going to use the bottom 4. And in here, yeah, so here we have the preload nuts for the anti-backlash system. So everything is fine. We're gonna use the 4. We don't need the side ones. We're gonna use the 4 screws, the corner ones, for equally load the nut. And yeah, and that's it, pretty much. So yeah, what I did was just move the ball screw as much as I could against the x-axis, so I could gain the space for this step in here, and yeah, and that's it. So since we talked about it, let's add so the third optional screw. Which I thought about it right now, and it's not a bad idea. So let's just make a 4.2 millimeter. Let's make it centered. My mouse is moving. Probably there's some dust on the sensor. And let's go from this to this. I don't know. We don't want much, but we don't want to mess with this step as well. -8. Yeah, here we should be fine. Let me inspect through a section analysis to see where we are. Yeah, we're good. Yeah, we're good like that. Well, actually, yeah, it's fine. It's fine. We can maybe get it a little closer. 6. We should be fine. Yeah, it's better like that. So we're gonna thread it, and we need to open the Z plate as well. And we're gonna do another. So here should be 9.5, I believe. It's the counter bore. Well, actually they have 10, but I think the counter bore for the M5 it's 9.5. I'm pretty sure. We can check. Let me open the... Okay, so if we go here, oh, actually, I'm gonna define the pilot. The pilot drill, I know it's a 5.2 millimeter. No, I don't want notifications here. Where's my mouse? It's here. So if we go counter bore M5, see, it's not an expensive tool, and you can buy even a cheaper one, but it's this kind of tool. So as you see, it has a pilot there. That thing doesn't cut. So it will act as a mill, but whoa. What happened here? Okay, let's go again. Okay, so M5 times 9.5 as I saw it. So the pilot will be, I'm pretty sure it's 5.2. Usually it is 5.2. Let's see if we have a spec. Yeah. So yeah, M5 it's 5.2. It's a nice tool to have around, even if you want to buy a set. It's not terribly expensive. Well, this one it is, but it's 7 pieces. Pretty sure it's gonna get to big stuff. So yeah, I recommend just the single piece. Doesn't need to be coated or whatsoever. The cheapest one will do the job. If you want to actually do it, it's just recommended. It's not absolutely needed. Okay, so it's a nice touch. So let's align with that one and see if we can. So if I remember correctly, we said 6 millimeters. I'm gonna make it 5.2. And you definitely don't need to go as deep as that one. You just need to clear the screw head. So if you're using a button head, it's like 3 or 4 millimeters for an M5 screw. Definitely no need to. So I'm gonna do 5.5. Shit. Yeah, I need to select cut. And we can do a chamfer just so it's not... That's just fine. That's enough. As long as you clear the top head of the top of the head of the screw, it's fine. No need to overthink it. It's just because the spindle will be here and the bracket will either you cannot counterbore it, but you'll need to modify the spindle bracket. So yeah. So this should be fine. And if we update the model, everything should line up. If I did everything right, Z plate, let's see if the holes line up. It's a little dark, but yeah, everything lines up. Here we have holes. Okay, other thing I made out of stream was we were so other change I made to the spec is this pulley, these two pulleys actually, because the original spec calls for a 6mm belt, and I don't see the point why using 6mm to transfer torque. This is not a 3D printer, so I changed it to 10mm belt for more force tolerant, because this thing will make some force. I'm not saying that you're gonna break every day the 6mm ones, but yeah, this is a no-brainer. Why do 6mm when it's pretty much the same price, or it's insignificant? The price difference for 8mm, you can use 6, no problems, that's fine. So I imported the models already, and we were having a problem about this leveling of the motor. So we needed to put the ball screw top was way much higher than the motor mount or the motor shaft. So what I did was I grew the piece. If you guys remember, the bearing block was on the face of the part instead of being down there. So I grew the part higher so I could machine the motor pocket as higher as well in order to lift the motor. And right now they are not at the same height, but this motor has a really small shaft because I made it small for the this guy in here. So this guy has 15.5mm. The original one will have at least 20mm. So it will have at least 5 millimeters more, which is more than enough to get in here. Actually, okay, yes, and this one has a 1/4 inch shaft. The original, the one I'm gonna use, it's gonna have an 80 millimeter shaft, 8 millimeter shaft, sorry. So it's gonna fill this thingy. Anyway, so this will be ready for the original motors, or the if you want to upgrade the steppers, it's fine, it's gonna work either way. And I just placed one. Okay, I'm seeing I'm gonna need to make a slot in here in order to we'll be able to access the pulley screw. Let's do that already before I forget. Where is this guy? So we're gonna place it in here. Let's create a midpoint. Just a square. Square. We create another midpoint so I can align them. This way it will be centered, and doesn't really matter. I'm gonna make it like 5 millimeters, and the depth is gonna be like maybe 3 millimeters should be enough, we'll see. So I'm doing 5 millimeters. We don't need that much, but I'm gonna need to machine these holes in here, and these holes are 5.2 millimeters diameter, so I'm going to need to use a 4 millimeter mill. So 5 millimeter, I can mill this slot with that mill, so it's fine. This should be enough. Let's take a look. Let me rotate the... So is it? Okay, it's not. Where is it? So it's on a column, it's here. So let me rotate it to the other side just in order to... We can check the alignment. Yeah, that's pretty much perfect. So now we have access to the screw, because we might need to tune it in order to align both pulleys. This one will be tight in on the top spot, on the top, so there's no problem there. But we're gonna need to tighten this thingy, so probably I'm gonna do a notch on the front as well, because we're gonna need to tighten these two screws in here. So let's do that. So what I'm gonna do is I'm gonna create a sketch here, and I'm gonna project this guy. Well, fuck. That's fine. and we're gonna do the same. And we have a notch, and let me do it like this. Yeah, it should be enough. It's a smaller screw head anyway, so it's a smaller wrench, should be fine. And yeah, that's about it for the Z motor. We can make this part more beautiful, but we can do that later. There's no need to waste time on here. So now maybe we should address the limit switches, or the ohm switches, or the ohm sensors, whatever you guys want to call it. I was just... I probably gonna enlarge these pieces, because these pieces, so these are gonna be machined out of aluminum, but this is gonna be a square block to machine this piece. So if I make this this thing in here any longer or wider or whatever, it's not gonna mess with the amount of aluminum I'm gonna need to buy, because it's gonna be waste anyway. So I may enlarge this in order to make a cover to just to avoid the ships from going to these ball screws. So these rails, the X rails and the X ball screw, they are not terribly showing, like unprotected, like the Y ones. So these ones are completely exposed to ships, but the ones on the X really are not. I don't. That's the only advantage I see on using this kind of table. I prefer to use. So if I designed this machine, I would do it very differently. First, probably, I would do it with two of these frames, using this same frame format, let's call it that way. I would use two of them side by side, and with a rail on, so one on here and the other on the further side of the C section, so to be wider and make use of the wide base in here. And then I would flip this and make it a saddle or a cradle where the table would move in. So instead of this small plate in here holding everything together, we would have a much wider rigid piece holding the table that would move that way. It's pretty much the way I designed my machine. So the only problem with that, it will expose the X ball screw, the X and the X rails exactly as much as the Y. Like, and this way they are actually kind of protected. They are not protected, but they are kind of not as vulnerable as the Y is. But yeah, that's design options. The guy opted this way, so that's fine. Okay, what am I seeing here? There shouldn't be any overlap, right? Yeah, it doesn't matter. It's just... that's weird. It's probably measurement thing. I don't care. It's not really important. Anyway, so let me open the, so let me close this, all of this. We don't need, for now at least. And let me open the original design. So the original design should be here. And actually I should open the version 1, not the version 2. Because I moved some stuff, didn't I? Yeah, I moved some stuff out of place, so let me open version 1. And this is why I like to work with simplified models. Makes it much easier on the computer as well. Okay, so they have the first. Let me look for what I want to use. I know I have a few because I use them on my router, and I know I have a few somewhere around here. Not absolutely sure exactly where. Not here. Let me change maybe to the front camera. You guys see me better. Okay, so what do I have here? Here we have some steppers. Some phone plugs. What's in here? Audio plugs, thermometers, USB, yes. We have some SSRs, some servos, here we have what? Some switches, plugs, some inductor sensors, switches, more switches, some buzzers. I have no idea why did I bought some buzzers. But I bought them for some project. I don't remember. Let's see in here. I'm pretty sure it was on one of these 4 boxes. Oh, here they are. Here they are. Are those the only ones? Probably they are. I may need to order a different type. What's this? It's a switch. Yeah. Those are the only ones. Okay. And of course, they had to be on the last box. It wouldn't be any fun if they were on the first box, right? At least this way I can have a small reminder of whatever I have on each box. Now I know I have buzzers. And if you asked me 5 minutes ago, I would say no way I have buzzers. I may have some lost ones or some on the used board or whatsoever, but no way I would say I had new ones in there in the box, in the bag. Okay, so these guys are awesome. So these guys are these, and they detect whenever, so they are super accurate. So they are accurate in this way, but they are actually super accurate on this way. So we just need to, god damn it. We just need to mount them somewhere and have something passing in here. And they have a light in here, you guys can see there, so you can actually check them out when they are triggered. So these guys are made to mount like this, like that. You see the screw holes, and actually they can also be mounted. They also have screw mounts on that orientation, so they can be mounted in 2 ways. Okay, these are not genuine. These are some... Yes, these are the optical sensors I'm gonna use. So these are the EE-SX 670. Well, I'm not sure if I'm gonna use these ones, but these are the kind of stuff I'm gonna use. They are super accurate, like in repeatability and whatsoever. I really like them. So these are supposed to be home run, but for the price they cost, I'm pretty sure they are more like foam run, so fake home runs. Let me take a look on AliExpress, which is my favorite store. If we call for EE-SX 670. So as you guys can see, there are several. We may need to order another ones. As you guys see, there are different mounting styles. I'm not sure how to... Okay, so it's the last name, right? Let's see if there's a... Oh yes, there's a datasheet in here. So these ones I have are these ones, the 670s. So we have several ways to mount them, or several models according to whatever we need. So these are a different series already. So mine is the... Oh, actually, yeah, it's the same thing. Just different mounting. The interior, the stuff in the interior, it's all the same. So we just need to choose whatever fits our needs the better. And yeah, use them. So let's see if someone actually cares to design this thing. So SX670 3D model, probably Mauser and that stuff. Yeah, so let's see how much it costs. Yeah, so we have steps, we have a bunch of stuff. So yeah, so officially from Omron they cost like 27 bucks a piece, which is not cheap at all. But yeah, I'm gonna use the clones. The clones are pretty much good enough for my needs. And if we check the datasheet, we can actually see, so these things can be used for encoder disks whatsoever. If we see the specs, like for so the repeatability on this thing is, so this is the distance from the top. This is not exactly what I want. So we have we can see the standard deviations. This is only from the side. So this is at different temperatures. We see from 2 micrometers to at 25 degrees, 2 micrometers. At 55 degrees, we have 4 micrometers. At minus 25 degrees, we have 5 microns. And D4, what's D4? So D4 is from 25 to 55. We have 2/10 of a millimeter. So yeah, that's but that's from a big range of temperature, and we are talking about ambient temperature. So, and that's a variation, so you need to variate from one to another to you have to start machining at 25 degrees, and there's no way the machine will never be 55 degrees inside of the box. So yeah, I'm not even gonna see the minus 25. So yeah, these things are pretty accurate. And again, they are more accurate this way. At least I had that impression. But they are only showing the... But, well, I might be looking at... maybe I remember from a older version. And this one actually are the same, but I'm pretty sure I remember having some differences from being from the side or from the top. I'm not sure. So maybe I'm wrong. I don't really remember. I need to take a look. Yeah, these don't have any QR codes or whatsoever, so these are as cheap as they can be. I was looking because I know they have 2 modes of operation. They have the dark one and whatsoever. Dark one. Oh, dark one is so when the so they can yes, they can work on dark on or light on. So basically we're gonna work with dark on, I believe. Yes, we're gonna work with dark on, which means So this works like with an LED pointing at a photodiode, right? And when the beam is interrupted, you can work either way. You can work like when the beam is interrupted, provide a high signal, or the other way around. Doesn't really matter. It change when the beam is interrupted. So how we want to work is the light, it's always on, and when we put something in the middle of the sensor, we'll interrupt the beam, and that will be dark on. So that way, if a wire breaks or whatsoever, the signal, we're gonna get the open signal. That's the point. So it's like they are where they are more accurate. It's dark on. So when we have an incident, the beam is interrupted, the LED indicator goes lights up, and the output transistor actually drops down. So it's basically active low sensor or trigger. Active low trigger. Yeah, active low trigger. So yeah, it's on this one. So we are using the 70A, which is one of these. And when we have an so the light is usually on, and when we interrupt the beam, the LED goes off, and the output goes low, and that's what we want. So we're gonna need to we'll need to check how to operate with this, but yeah. We need to shunt, believe 1 and 2. Yes. Open between, okay, dark on, it's open between L and the plus, so these ones are open. And if we want to work with light on, is we need to shunt those two, so we don't need anything of that. Anyway, so we are looking for the models. That's what we came here for. So we have models here. And let's download the step. Yeah, that's fine. So we can go to, oops. Okay, I'm gonna need, give me a minute. I'm gonna need to download it on my Fusion computer. Sometimes I forget I'm working on with Fusion on another computer. Multiple online threads. Jesus. Okay. Function assembly, and let's upload, select files. So I'm just uploading the model, which is called S, I believe. Nope. What is it called? E. Okay. Upload. Okay, I can change now. Oops, not this one, this one. Okay, I changed. It's uploading still. It's converting more actually. Okay, so on we don't need to work as they do, but might be helpful. Okay, since I want to connect this thing to here, not sure still how, but that's the idea. I'm not gonna put anything on the sides, or try not to. On the other way, I really want to see if we can, oh fuck, yeah, I forget, if we can do some kind of cover in here. And let me check let me update the design. Hey AAA, long time no see. How was your Christmas? Okay, let me hide all the joints on the model. Just because, okay, we don't have any here. Okay, why saddle? Joints off. Joints off, joints off. Why? Oh, new PC. Christmas gift? Or Christmas gift to yourself? Global mount, x-axis, joints off. Okay, we have still a couple of them, but let me see if I can locate them. Oh, that's nice. That's nice. Okay. I'm not sure exactly where those bastards are, but they don't really matter. Not gonna bother. Laptop or desktop? Okay, so we have this space here. This space is actually nice. This space is actually 39 millimeters. It's a good space for the way cover. My main complaint would be on this side, because this side, so I'm pretty sure my limit is gonna be this touching this. Okay, where is my spindle? I'm missing the Z-axis. I'm missing the spindle mount. I need to move my spindle down. So I assume I need my joints. Let me edit this joint. Where is she? Okay, so we are here. Which is here. Let me roll the history here. Okay, so probably this is a... I need to move this girl down. For now I'm gonna move it like... just like that, doesn't really matter. I just want to make sure, yeah, that's fine. Yeah, of course. I need to... How do I do a capture position? Okay, what I'm gonna do is actually I'm gonna delete this joint. I'm gonna do a shift as built. I'm gonna make a new one. So this way, yeah, okay. This way I can. So this is just to see where my spindle. Okay, let me limit this joint as well. So I assume this joint, yeah, it's in here. So it should be this one. So I'm gonna put it to touch align components. So they give you a full desktop or in parts and you assemble it yourself? So we have 17,135. So I'm gonna edit the motion limits and I'm gonna, it's minus. Yeah, that's the fun part. That's cool. Okay, and now, yeah, now it's self blocks in there. Okay. So what this means is like this. So we are getting the you sure it's because of the CPU? It's not something like, because every new machine nowadays should be Windows 11 capable. Isn't it something like secure boot or something like that? I need to do inspection. So what I'm checking here is pretty much how far out of the table we are. So we are 2 millimeters out of the table in Y. Okay, so looks like we have more travel. What am I missing? I'm probably missing something. So actually we have way more travel than we have table, which is good because my so what we can do, we can grow the spindle mounts a little bit, something like 5 millimeters, not much, because we want the spindle as close as the column we want, but in order to get a little more from this side, we can grow the spindle mounts a little bit, so we can have a little more travel or access or reach, whatever you guys want to call it. So I'm going to increase these to 56, and everything else should stay the same. I'm pretty sure it won't hurt anything. And yes, I know you want the spindle as closer as the column, as better, but this way you'll have a little more reach. Why isn't... Is it updated already? Oh shit, okay. Okay, I need to modify that that joint. I need to modify this guy. Otherwise it won't update here. Okay. I'm gonna roll. I'm gonna delete it. I'm gonna join this guy with a regular joint, rigid one, and now I'm gonna move it down. It's just so, yeah, that's fine. It's just so I can see the difference. Roll history. Okay. Okay, so we have the limit there. And yeah, okay, so this way we have a little more reach to the back of the table. It's just on those cases of very limit, because here we can go far out, actually way outer than we need. Not sure why they made it so big. Maybe we can hang stuff from there. So from here to here, how much space do we have? 230 millimeters. Okay, I need to do some questions. We really don't have much. Okay, let me do something on the table. Where did I build the table? So the table should be here, here, table. Okay, let me activate the table. Well, if you install the Windows 10, I'm not sure if he's complaining that your hardware isn't doesn't meet the requirements. I'm not sure if he's gonna let you update to Windows 11. I'm not sure. Just saying, because my laptop, it's the only computer I have with Windows 10 yet, or not yet, but only. No, actually I have another one that doesn't have it, and it's because it says it's not it doesn't meet the requirements, gladly, to Windows 11. Okay, so something, as you guys know, that I want to do is to fill this stuff with with epoxy, at least like this. Probably it's gonna be, oh, updating the BIOS should be the first thing, one of the first things you should do. I agree with that. Okay, I'm gonna do the same on this side. So this one it's like that, that one it's like that. I'm not sure about dimensions or anything. I just want to have an idea, because I really want it should be something like this. Well, let me do 5 millimeters. And this thing, it's gonna be filled with epoxy granite. Down there. So let me make it like that. It should be around. Why? I meant this one. This one, it should have a round edge of something like 5 millimeters. I'm not sure. It's not going to be super precise, but I just want to feel it so I know that space is gone. Where is the auto mode? Okay, this way I know this space is filled, so no point of having stupid ideas about fixing stuff there. Now probably, this is the good thing about epoxy granite. We can anchor some nuts and stuff, because it would be good. It would be nice to have some kind of guard in here. Or we can even 3D print some shields. Something like, I'm just gonna make something kind of ugly, but so you guys have an idea of what I'm talking about. Something like this. I'm gonna project this guy, and I'm gonna project this guy, because we can touch it. I'm gonna do the same on this side. So we can put it actually from here. Let's call it 2 millimeters. Like this. Doesn't need to be too big. Can be something like that. And something like that. We can put a size in here, just 10 millimeters, why not? Just to be, so that's parallel to that one. What is, oh okay, it's the, okay, we can put the, no, dimension here, just the same. As this one, 2 millimeters as well. Same story in here. 2. This is just to show what I here to here. So here, yeah, this one parallel to this one. This one. Fusion. Come on, Fusion. Cooperate just a little bit. 2 millimeters, and what is the thingy? Oh, it's here, 10 millimeters, right? 10 millimeters. Something like this. E to that side, and I'm gonna make new bodies, create bodies. Shit, did I? Okay, it doesn't matter. I forgot to. This should be on the. Yeah, this should be on the table. It's fine. Yet it's not. Okay, let me delete them then. Let me activate the table. I forgot to select. I was working on the. Okay, so I'm gonna project this line and this line. This line. And oh, either I fucked up the lines. Well, doesn't matter. So yeah, actually, now that I'm thinking about it, it was wrong. I'm gonna correct it now. Okay, so this one and this one perpendicular. This one is parallel with that one. This one, yeah, everything is kind of fine, I believe. This one and this one, yeah, everything is fine. So 2 millimeter, 2 millimeter. And 2 millimeter, not like that. And 1.5 millimeter from there. Same story here. Sorry, 1.5. And maybe 10 millimeter here. I need to do the same on the other side. I could mirror it. Yeah, I could mirror it. Okay, let me do a line. There's the middle, it's here. Like that. Okay, I can create mirror and yeah, like that. Like, I don't like to do that a lot, but I'm lazy today. Okay, so fuck, okay. Is it? What's wrong? Oh. Because that oh. Ugh. That line, it's not. Okay. This one, it's for sure. It's sketch. Okay. Create mirror that thingy over this thingy, fine. And we are good now. So the error was I created a mirror on this line, but this line it's not centered. It's that thing that the guy that designed this thingy doesn't like symmetries. Okay, so this is what I was talking about. And so with these cards, oh fuck, I intended to leave bodies. So these guards are nice because it will prevent you. It doesn't seem like a lot, but it will guard the it will shield the rails from ships a lot. And actually we can do the 99. Okay, that's fine. We can do the these pieces. Same story. We can make them wider. Not sure why is that line there, but oh, okay, yeah, I understand. It shouldn't, yeah, it doesn't doesn't mess with anything. And again, this is not definitive, it's just and actually it's better to, the only thing, it increases weight, that's no problem, it's not much anyway, it's not significant, and actually it takes less time to machine because it's less material to remove. And there we are. So you see these guards will actually be helpful. So we can't actually close them because we need the table will move and we can't now we could make them more in here, but so the ships wouldn't go on top of this plate, which is actually a good idea. We'll see later. We'll see later. Yeah, I really don't like the sheeps trapping in here. And they will. And they will. Okay, something else I want to do. Okay, let's do that as well. Okay, let me look at the Milo. Yeah, we have some stuff here. Wait. Oh, I see. So they want us to insert. Nah. Okay, so they want us to insert these thingies. In there, and then the screws go down there. Okay. I'm not sure if I like that idea. Wouldn't it be better just to do a few threaded holes and don't mess with the screws that hold the carriage? I would do that. I wouldn't mess with those screws. Those screws need to be as stiff as possible, and they threading and in plastic. It doesn't feel like the best. Nah, I'm not gonna agree with that. Nope, sorry, but no, I'm not gonna go with that idea. I prefer to add a few screws threading on the plate if I need to. Why do they even? Okay, yes, they do. For the motor, they do need the drag chain. Well, need is a strong word, but our music paused. Okay, so well, first, I'm not sure I'm gonna use this drag chain. I really like drag chains, but I'm not sure if I'm gonna use this one. And if I can use the that end stop if I can use the this limit switch in here instead. Well, if I don't use the... Yeah, we don't need drag chains at all. We don't need drag chains on the base at all. I mean, we need, but we kind of don't need. And I'm the guy who loves drag chains, so kinda... But I think here they do more harm than... Well, for they would come handy for the probe, the tool probe, but I don't even like their tool probe, so... And I especially don't like the mount they made for the drag chain. Olá, Margarida. Well, the end stop on Y, it doesn't need to be drag chained, because on Y it's attached to the base. Even if it's not in here, it's going to be close to here. So that's the least of our problems. On the Y, yes, it can be on the X, I mean, it can be here next to the motor, but the wires can hang around. It's not like this thing has a ton of movement. But the only thing for the drag chains, I don't like the mount they made for it. It's the... Okay, first thing, I can't mount it like this because I'm gonna fill this thing with epoxy, and that's what I'm gonna do now on my model. I'm gonna create... So I need to select the base. I'm gonna select the base. Yeah. Well, maybe I'm gonna select the saddle instead. Yeah, the saddle will be better. So this thing is where? Okay, it's exactly here, so that's what I want. Okay, let me disable this guy. I make a new capture. yeah, I'm gonna go crazy and just go from here to here and coincident and 45. I'm gonna do the same on the other side. I want to fill these thingies with epoxy granite at least until here, maybe a few millimeters like that, and possibly I'm gonna even then build the rest in here. We'll see how I will decide to do it, but that's a high possibility. Let's call it 18 millimeters, and let me do a project on this guy. No, actually I'm gonna delete this and I'm gonna make it collinear to the other side. And extrude to here. Yeah, I would like to join, but let's say it's until here. I'm not sure what have I done in here. Edit feature. Okay, here I want to new bodies. Yeah, these are the fillers. Okay, and now okay, I can do this. Like I believe I can do this, right? Yes, I can. Okay, so it joins to that one and not to the other one. Okay, that's what I want. Okay, so this is something I intend to do as well. Okay, so we have space. We have plenty of space, even with my guards. My guards are here, right? Yes. Yes, my guards are there. Okay, let me highlight all of these now. So okay, we have space. Even if we want to do a drag chain more on this side, we can do it. I can finish this block a little further on the back. Or even not doing it, but or even better, we can make a mount that mounts on the we can make a mount that mounts on the epoxy granite itself. We can put a nut, and then when we fill with epoxy, the nut will be attached to the epoxy, and we can use that mount or two to to mount the drag chain, even if we need to make an offset mount to move it a little bit to outside, that's fine. So it works in here. It's gonna be a sheep catcher though. I think it's more, I think drag chains on this machine are do more harm than good, if I'm honest. So I'm not sure about them. The only thing that makes me miss the drag chain in here, it's the tool setter, but even the tool setter, I'm not sure even if I'm going to use a tool setter, but even if I do use a tool setter, I can easily run the wire. I can mount it on this corner and just put the wire together with the motor and the sensor screw. So yeah, for now I'm gonna ignore the drag chains, because the drag chains on this machine really don't feel like a good thing. Because if we're gonna use a drag chain in here, it's gonna catch a bunch of ships. It will. It's not a question of if, it's just a thing. It will grab all kinds of ships. And if the ships get stuck between the drag chain and the cable, I believe it can do more harm than good. So I think the best thing is actually just run the cables. It's not that much either. It's the ones from the motor and the ones from the end stop or the home switch or whatever, which I'm gonna put on this side. It should be the same. Maybe on the lower side. Let me check something. Ooh, oh yeah. Oh yes, on the lower side. That's the deal. I'm gonna put it on the lower side, because it's the least probable place to get ships. It's on the lower side. So there's exactly where I'm gonna put them. So not in here, I'm gonna put it in here. And the wires will go together. Yeah, that's it. That's decided. No drag chains. I'm gonna use a drag chain on the Z, because the Z makes sense. Let me check, where do they have the drag chain on the Z. Okay, so we have it here, there. That's a printed part. That's fine. And yeah, I don't like these either. But I guess we can machine the spindle mount with some side screws and mount it there. That's fine. Probably I'm gonna need to flip the spindle mount, but that's fine. Yeah, okay, so we are good with that. I just need to machine to make some side mounts on the some side holes in here on the spindle mount, and we should be fine. I think my spindle, yeah, okay, we should be fine with that. I'm not sure about, probably it's gonna mount in there on that hole, I would say. Not sure. Yes, I'm pretty sure those two holes are for these two pieces. So we should be fine. This is a guide for the drag chain. Should be fine. Okay. Okay, we are in business. Okay, so I'm gonna take care of that guy now. It's gonna be awesome. I just need to add 2 more screws in this plate, and it's gonna be fine to mount the... Any questionable choices? How are you, my friend? Good? You had a good Christmas? Okay, so let's do it. I'm gonna select the saddle. That's all we want. Everyone happy with the Christmas. And let's add the how is this thing? So this thing is the other way around, so the LED goes the other way. And like that. Okay, so let me measure the holing. So this thing will accept 3mm screws and 19mm apart. So let me open the motor mount. Yes, I think this machine will be very capable with my modifications. I think it will be very capable. Okay, so let me open the X motor mount so we can do some holes in here. What do I want? So 2.5 millimeters, that's for sure. 2.53 wouldn't be a problem. 2.5 aligned, and they will be 19 millimeters up. Oh, I'm gonna do different. Fuck. X, I'm gonna create a midpoint. As you guys know how I like to do it. Shit, midpoint. And another midpoint in here. So I can align them. And the way we're gonna do it, it's okay, I need to check. Just thinking the best, easiest way to do this. Yeah, the best way, it's like this. Okay, so from these to, I need to take a measurement from here to here, whole ball, and we have about 17 mils. That's a lot, but we have a thick mounter mount. Why isn't it fully defined? Oh, because I forgot to put 19 millimeters here. -5 doesn't need more than that. Let me check where they are. Inspect section. Let's go like this. Yeah, we are good. We are good. Okay, maybe let me do some changes. So this way we are oh no, we have a gap. Oh, we have a gap. We are ready for that then. Okay, so that way I'm gonna push it a little bit to the front. Like 15 instead of 17. This way we are in, so I can make the holes a little deeper. -8, boom. exactly. Well, maybe I'll go even a little more. No, that's fine. That's fine. That's fine. And now we have the holes there. I may leave, I think I'm gonna need those. I'm gonna leave those in there as well. If people want to use the original switch, home switch from the kit. I don't see a reason to, but and we'll make the piece more expensive because it's one more setup. We'll see. That's it. And actually we can make it more to the front. Okay, let's make it more to the front. Let's make it more. Let's make it full front. So something like 3 millimeters more. Let me remove the analysis. More. Here. Even more. Let's make it more. 10. Then it's perfect. And we are good now. Now I need to open the... Yeah, we should be fine. Yeah, we should be fine. And now what we're gonna do is I'm gonna open the saddle plate. Which is this one. Right? I think so. Now let me orientate it as it is. So let me check. So the one screw is on this side. And with the counter bores to the downside. Okay, so it's like this, exactly like this. No, it's like this. Okay, so I'm gonna create another. Now I'm not sure how I'm gonna do this. So one screw or two screws? I think two screws would be more secure. Yeah, let's make a new part. And let's call it, well, let's not call it nothing for now. Let's create two slots, can be center to center. So 3mm, 3.2, and can be 5mm. I'm going to create half the part and then I'm going to mirror it. Fuck that. Control C, Control V. I don't like that shit. I want this one align with this one, and I want something like this. This doesn't need to be big. On the contrary, the smaller it is, the better. As long as two heads. Let me create another two slots, center to center. Coincident with this one. Let's make it 6mm, and let's make it construction. And another 6. So this is so I can have an idea. Okay, we can go way less. Okay, 10. 10 looks good. 10 looks good. And what do I need more? Now I need, let's make a line surrounding all of this. Okay. These ones like that, this and this like that, this and this. 5mm should be fine. This should be 18 maybe. Let's make it 20. No, 19. So I can use 20mm aluminum. This thing can be 2mm, 2.5mm maybe. And 5mm, it's more than enough. Hey, I need you and you perpendicular or vertical, sorry. What do I need? Okay, I need to create a midpoint. And this should be this one. No. What am I doing? That's not what I want. It's this. So it's this one divided by 2. So it centers. This one, okay, there is a, okay, it's there already. No point. We push it here. Okay, so now everything. Whoa. Whoa. You are supposed to be the midpoint. Okay. Now I need to create a midpoint as well in here and align it with this one. like that. And okay, let's call this guy 15. Okay, here maybe 8. Yeah, that looks good. And 30 looks good. 28 maybe. Yeah, 28 looks very good. Okay, so let's do 3mm. No, needs to be more. Yeah, can be. And so 5 maybe should be fine. Let's do some rounding around. Can do something like 4. Wait. Why didn't you round? Okay, because I forgot. 4 looks good. Then let's add some tooling shit. Let's add these and these. Can be 2. Okay. You want me to do it separate? I'm gonna do it separate. There's no problem with that. 2. What about this one? Oh yeah. 1.5 maybe. Oh yeah. Oh yeah, me likes that. Me likes that. Okay, so I'm gonna call this X ohm bump. Ohm bump. No, not amp, bump. Our friend YouTube died. Yeah. Okay, so this is just the piece that we need to draw 2 holes in here. 0.5, 2.5. $10mm apart. They are vertical. And now I need to check where it's gonna leave. First thing I need to check is how far is this? Okay, 8mm is perfect. Now I need to check how long is from here to here. Okay, 64.5. And there's 5. Okay, 62 millimeters from this side. So let me make a line X and a point and D from here. 62. Yeah, because it would be too good if the plate was centered, so It would be too good for it to be true. And for now, I'm gonna call it 20 millimeters. It's gonna need more, but for now, let's call it that. So we need to drill 2 holes in here. Let's do -7, no point of going to the other side. It can go, there's no harm. This is gonna be a modification again. So let's save it. Let's see if it's in the right place. Yes, it is. Well, it won't be that far. Okay, I fucked up. This one needs to be on the x-axis, capture position. Right? Yes. And this one, it's gonna be, so let's put in our exome bump. Okay, I need to rotate it 180. Fine. And let's put this thingy with that thingy. Join. Boom. So let's see. Ooh, actually, yeah, actually we are good. No, probably. So if I remember correctly, the trigger point on this thing is it's about 3 millimeters. So let me measure this face. To this face. Okay, so we are 4.65. So I need to push it back at least 2 millimeters. Yeah, 2.5 millimeters. I'm gonna make actually the travel a little longer. Okay, let's make let's make this guy 8 millimeters travel actually. Let me put this one together with that one. Wait, oh, okay. So actually, yeah, okay. Actually, this one, it needs to be 8. And this one needs to be the same as this one. Okay, that's it. What we need to do is increase to 18 and increase to 31. So we have more travel, and no, not in here. In the saddle plate, we can at least, what? How much was I saying? 2 millimeters for, yeah, at least 2.5 millimeters. 22.5 millimeters. And we should be finish sketch. We should be good. Let's see now. Okay, so let me check if we don't, yeah, we have space. Okay, so the idea here is I'm gonna even push it back more. So the idea here is to, do we have space to adjust it? Yes, we do. Worst case scenario, we need to cut worst case scenario, we need to cut well, if I put it more to the back, well, I can't. Yeah, needs to be like that. I can make it shorter though. Yeah, it's fine. So the idea here is to, yeah, we don't need it as long as I do. Yeah, it was way better with the 5 millimeters. It's more than enough. So 5. So these plus 12 and these plus 14. No. Plus 10, 15, 20, 28, plus 13. Okay. Now, if I adjust the travel, everything should move forward accordingly. Let me put this thing in here. Yeah, fine. Yeah, this can be a 3D printed part, but of course I'm gonna do it aluminum because I wanted to be more precise on the optic sensor. And guys need to be careful because of the optic sensors. If you do this piece in plastic, it can, some filament let the infrared light pass and can be problematic. Okay, this should be fine. Face. That face against this face. 2.5 millimeters, fine. So we have room to adjust it because this thing is supposed to, well, maybe that's even a little too close. So I'm gonna move, yeah. I'm gonna move it, nope. Let me close this. This I can close as well. This one as well for now. Yeah, let's give it a little more. v1.5. Okay, fine. So yeah, so see, the idea here is to adjust this piece to be adjustable. It's going to be a pain to adjust though. Hey Dono, how are you? Well, if we push it all the way to the front, yeah, it should be accessible, kinda. And boom, goes there, we adjust it. We can do some CAD and actually do a measurement that should be adjustable in there. The screws for the holes for the sensor are actually a little bigger, also provide some adjustment. So we should be fine on the X ohm switch. So you guys may ask, why the hell do you really want a super accurate ohm switch? Well, in CNC, you can, it's not like the 3D print, you can be machining a part and suddenly the power goes out and the machine stops, and if you don't have absolute servos, yeah, Christmas was good. Lot of eating, lot of drinking, lots of fun. Kids playing with new toys, not so much kids playing with new toys as well, or a little older kids, let's call it that way. It's always fun. Christmas, it's always fun. So as I was saying, so if the light goes out, or if you press the holy shit button or whatsoever, then you need to re-ohm, and if you re-ohm it, and if the ohm is close to where it should be, or the closest where it should be, then you know your offsets are right again. But if your ohming are off by like a few cents of a millimeter, then you'll be off a few cents of a millimeter. If you still have the origin references where you can just probe your part again and get on with it, that's no problem. You can use whatever ohm switch, it doesn't really matter. But if you need to restart something, or you haven't finished machining the part on that day, you're gonna continue the next day. Yes, I know, if you're not on a climate control where the temperature of the machine oscillates, everything will move. But with good ohming, it's always better than bad ohming. That's why I prefer to move for something more accurate for ohming, other than these shiny switches. And we can do some testing with these cheap opto thingies. They will be accurate to at least 1 cent of a millimeter. Anyway, so let's go for, let me check how they have the, so this is the, okay, so the ohm bump, it's there, the x-axis, it's there, okay, everything is fine in here. Let's check the Z. Okay, so we have they have the ohm switch in here, which is okay. So let's check where can we place ours. Oh, why is my let me see if I move. Yes, I did. Okay. My pulley is flying around. How can I? No. Okay, let me align it. Wait, the hell? Align from, okay. Let's align the top. And this top should be aligned close enough. And now I'm gonna shift join. Okay, just like that. Should be fine and not running away anymore. Yeah. Okay, so let's see. We can do the where we can do the ohm switch on here. Well, ideally we can use the same piece for the Z. So let's try to do that. So for that I need to grow this piece 10 millimeters, which is quite a lot. So we can do a spacer. So we have two choices. Either we do a spacer, which to be honest seems like a good idea. Or I need to grow that part 10 millimeters, which is 10 millimeters more of aluminum. So either one more piece, well, the spacer can be printed. There's no problem printing the spacer. Or making the part bigger. Decisions. I think I'm gonna make the part bigger. Prefer. It's one less part than that we need. So, and we can use the same bump. Yeah, let's do it. Let's make it bigger. Hey, Antonio. Jesus, that's not good. I like this time of the year. I hate only Christmas music, but other than that, okay, let's make the part bigger. Bigger parts. Where is it? It should be the Z, this guy. So it needs to be 11 millimeters bigger, so 137. I think it's this guy that needs to be 42. Yeah, it should be something like this. Now we can make these chamfers bigger. That's one thing we can do. Like 20. Should be fine. And now we need to do a few holes in here. Let's do a 19 millimeter line X. Let's create some points. Midpoint and midpoint, and let me align these guys. If I remember correctly, it was I can't remember. I think it was 10 millimeters here. And we have 2.5 and 2.5. I think it was something like this. We'll see. Minus 10 shouldn't be a problem, since we grew 11. Let's see. So the idea now, it's this face is closer to, yeah, it's higher than this. Fine. So let's select a column. So we have the z-axis. Okay, yes. So let's place another where is that guy? Where is our, it's EE, yes, it's here. Okay, so like that. And J. Yeah, it should be something like this. And now we need Z-plate. And we need the same story here. Line, so this line is 10 millimeters apart. X, create points. Okay, shit. I need to project this part. I'm gonna assume this one is centered. We're gonna find out in a minute or two. Like this. And 23.5, I believe. And again, 2.5 millimeters. Again, minus 8. No need to drill this thing all the way. Let's see if we are good. And now we're gonna select the Z axis, which is here. And we're gonna import our bump, which is gonna be renamed XZ bump, because it's the same part for both. Hopefully it's going to be the same part for all of them, which makes it much easier to machine all of the 3 at the same time or equal instead of one of each. And the idea is to be the further away. Join. Boom. So again, it's going to be adjustable. Let me move the spindle away. And we can adjust the position. As we want. Okay, so the Z stop, it's done. Okay, let's take care of the Y Z stop, and I'm gonna call it for today. So probably we're gonna do the same thing. Oh, the Z, it's gonna be harder actually. Nah, it's gonna be fine. Yeah, the Z, it's not the Y, it's gonna be harder because of the what am I missing? I'm missing something at the salon. Yeah, this guy. Okay, actually it's gonna be, we can make it easy. We're gonna use the same part for the shit. For the Y axis, we're gonna rename it to XYZ ohm bump. But we're gonna need 3 of them. Shit. And I'm gonna need to modify this. I'm thinking. So let me call Z plate, Z mount, a saddle plate. We're gonna need it again. So this one, it's like that. I want to mount it on the bottom as well. But I want something different this time. Blocks. Okay, I know what I want. So 10 millimeters. We're gonna finish this, and that's gonna be it for today. So we're gonna need two 2.5 millimeter holes. X need points. Midpoint. Let me create this project line. Create point. Midpoint. Actually, I haven't checked. Let me check. That thing is centered. Should be. Yes, it's centered. Yes, it is. Centered enough. Okay, same story. Align. But this time, let's start with 12 millimeters. We'll see where we get. So it should be, no, less. I want, so usually I do 23. I'm thinking, well, let's not waste our neuroniums. So let's go the lazy way. We'll see after. So let's do -8 as usual. And I'm gonna select the saddle. Actually, the actual saddle plate. No, yes, the saddle. Yeah, it's like that. We don't want the, yeah, it's the saddle. So if I did everything wrong, 2 holes should appear somewhere in here. Yes. So let's insert the ohm bump. What do I have to do? I have to invert it that way and that way. Now you go there. J. Yeah, that should be close enough. That should be close enough for what I want. Now I want to make a piece which is, oh shit, I can't do what, no, I can do it, so 16, okay, so we're gonna make a new piece, which is gonna be something like like this, like this, like this, like this, like this, like this. Let's make it simple for now. Okay, we're gonna make it like 18 in here, 18 in here, 60, right? I think it's 16 here. No, huh? Yeah, 60 or 40, 40, 40, 40, 40. 14 here. And 17 in here. Can be something like 23. I don't want it to be higher than this, so this is from here to here. 26. Yeah, 24. 24, it's fine. Why is what's wrong? What can I do? Oh, okay. This one is collinear with that one. Okay. 20 for now. Okay, 2.5 millimeters in here. 5.2 actually. As usual. Create points. So we need a point here. Oh no, actually we don't need a point there, but now it's done, it's done. I need dimension from this guy to this guy needs to be 60, and from this guy to this guy needs to be 60 divided by 2, and from this guy, no, actually we're gonna do it from this guy to this guy, 17. No, no. I'm messing up. I'm messing up. This one, it's actually aligned with this one. Now we need another set of 19. X, C, 2.5. C, 2.5. Create a point here and here, like that. And this one, we're gonna start with 17. Like that. I'm gonna do some stuff that I need to do in here to make sure everything fits. Oops. Forgot these two. Whoop, all the way. We can do some chamfers in here as well. Like big ones. Something like 20. Okay, not 20. 15. 15 looks good. before this, let me do some counter bores. 9.5, 9.5. He down to here. Let's give it plus 11. This could be M3s, to be honest, but that's a long way to drill. So let's go like that. Yeah, that looks good. That looks good. Let's see how it feels. So this is gonna be the Y home mount. We might need to modify this thingy, but we'll see. For now, so I'm gonna put it here, and I'm gonna put the Y. So we need the Y thingy. Y home mount. I need to rotate it. That. Okay. Now, so for now, I'm gonna mount it, align it with this. I'm gonna align this face with this face, and this face with this face. Okay. Okay, I'm gonna need to desalign it a little bit. But the idea is this one to be 1 millimeter away, which is fine. And now we're gonna mount the $180, and let's put the light down, and this guy gonna join this guy. Components. Sorry. Shit. I want to join. I want this guy to go there, so I need to select it first. Otherwise, the part will go away. Okay, so it should be like this. So let me select everything. So this is the first idea. Now let me do analysis, but not this one. I need a different... Shit. Okay. I'll delete them all. Inspect, section. And actually I want to investigate stuff like this. A little more. Okay, so this is what I want. So this one in here will be fixed. I'm going to use the same part because I'm not going to design this, a simple one. So it's going to be all three. But the idea now is since this piece is mounted on the actual frame, we can slide it whatever we want and adjust the home position, which is the whole idea. So just want to select it. That guy, move. Let's move it like 5 millimeters to the back. Actually, let me align it with this guy. Let's check. Let's see how it is now. Yeah, that's pretty much where it will trigger. Should be about 3.5 million. Yeah, okay. So we are good. And this way, my idea. So even though that I want to, okay, let's do a rigid group or rigid mount before I forget. So we can attach the sensor in here firstly, and then we can just adjust the position here on the frame, and yeah, we should be good. Yeah, we should be good. So that's it for today. Tomorrow we're gonna try, so all homing is done. As I said before, if you weren't here, but as said before, I'm not gonna mess with, I'm not gonna mount drag chains on X and Y, only on Z, because I don't like how they are mounted, and since I want to stiffen this connection in here and on this side, and there's no point of, I don't like that one, so I don't like the way these guys made this one, and to be honest, I'm not even gonna bother to try to figure it out a better way to do this. I'm just not gonna. I don't like the way this mount. So these guys, the way they made it the mount for the drag chain, actually for both, will use these screws that goes to the carriages. So these thingies will get in the aluminum plate and actually tight everything together. I don't like it. I prefer to use the screws to tight it directly to the cars and don't compromise rigidity because of it. And also this drag chain in here, unless we cover it somehow, it's going to be a magnet for ships, and I don't like it because the cable is going to be inside, and then ships will go inside, and with the movement pushing everything back and forward, I really don't like the idea of this overall. So yeah, fuck that. We're gonna use the Z1. The Z1 looks good. I don't see any problem with the Z1. even that we don't have a ton of cables going on. We pretty much only have one cable, but yeah, so we're gonna mess with that. We're gonna use that. We probably, I'm not sure if we're gonna use this exact mount. Maybe we can do. So it's one less piece we need to design. Yeah, I think so. It might take a long while, but it's not a good idea, and it doesn't help anyway. It's better just to have it's just two cables anyway. It's the cable for the on switch, and for the motor it can be just floating. This machine doesn't have a ton of travel anyway, so it will move very little around. There's no point. I don't see a point, at least. So yeah, we can ignore these and have more space to figure out how we're gonna cover these. How we're gonna cover the machine, the ways, the rails and the ball screw, because I really want to cover these somehow with some kind of accordion, or I don't know what you guys call it, an accordion cable or cover or something like that, which we need to figure it out. In here we can print some covers. We're gonna need to print some covers in as well. We'll see. Probably we'll need to further modify the part with more threads. So yeah, but that's for tomorrow. I'm gonna actually, yeah, probably tomorrow. I need to take a look at what kind of covers can we get for this, and then we'll go from there. On the front side, I'm not too worried. We can just, because we have space, we can just do a big cover to cover everything, from like a big one, even from here, from this side to that side. I'm not too worried. We have space. The problem is on the on this fuck. Problem is here. So let me open mine. That's why I like my model. The problem is here. We have very few space in here. So we pretty much only have this space from here to here, which is about 30 millimeters. I need to figure out how much can we, and we have all this travel to cover. No, I'm not gonna go 3D printed. Yeah, bellows. I'm gonna go with, I'm gonna have some stuff manufactured on AliExpress. It's gonna be cheap. We are talking about even something like $20 per cover or something like that, and it's only two, because we don't need for the X, because the X, it's pretty much covered as much as we can. I'll need to think about it, but I don't think there's anything we can do for the X. I kind of don't like this design because of that. It's hard to protect the X. We could do these things, it would be better, but no, it's the same. It's the same. Doesn't matter. No, in nylon. These things, this stuff. Where? Give me a second. CNC away covers. So something like this. These things compact very much, and it's cheap. It's cheap enough. We just need to figure out a design. That fits, and I need to figure out the compression rate. So, but yeah, these things are super cheap. I had some of these made for my big machine, and they were like for what they are super cheap. I paid like, I believe something like 300 euros for 5 of them. All like this, with sheet and actually on an angle like an house, like this. And they are super big. They are like, the X ones are like this, and the Y ones are like this, and the Z ones are something like this as well. It was super cheap for what it is, of course, and it's super resistant. The material, it's super resistant. So there's no point. There's just no point on. We just need to figure out something that works and where we're gonna grab it and whatsoever. Then there are more complicated ones, but these guys make everything. So, but for the sizes we want, it's gonna be super cheap. I can show. So save. I can show. Let me close this thing. Let me close this. Close. 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 Don't save. So BMESP. Where is it? I think it's this one. Yeah. So mine. So where is my machine? It's a big project, so it takes a while to open, and my computer isn't the fastest anymore. It's begging for an upgrade, but money doesn't stretch. it was a very nice processor back then, but now it's just obsolete. So as you can see, mine are big covers. And these things, so if I move the table all the way here, so this size, all this length in here, which is 750 millimeters, will compress into this length in here, which is 135. And the same for the Y, so from here to here I have 450 millimeters, and it will compress down to 100 millimeters. So yeah, that stuff works, and it's super tough. It's not like with mine have 5 years of working every day and they are like new. When I clean the machine, when I wash it all over, it's brand new. It doesn't have a dink on the bellows. So I think we should be fine. We just need to figure out how to mount them. Nice. I've been doing some research on that, and I'm not sure what I'm gonna do yet. I'm gonna go with Linux CNC for sure, but I'm not sure. I have a few options, so let's talk about a little bit about that. So first, I don't know still what computer I'm gonna use. I have 3 options. I ordered a mini PC yesterday from Amazon. Should be here tomorrow. A nice all-in-one PC, 12 Gen CPU, quad core, whatsoever. Very nice. People say it's awesome for Linux CNC. It's a quad core, 2.8 gigahertz, 256 SSD, 8 gigs of RAM, all-in-one computer, no fans, no nothing. Pretty much like a Raspberry Pi, but people say that it works way better with Linux CNC other than Raspberry Pi. Then I have the Raspberry Pi 5 with a NVMe whatsoever, which should work fine as well. And I have a board that I bought back 7 years ago, which is pretty much an all-in-one computer as well, but it's a mini ITX board. It's a dual core processor, but it should be fine, and it has parallel port, which is very important because we can use Linux CNC with a parallel port, at least to try. I'm not saying it's the best solution, but at least to try we can do that without any extra cost in Mesa cards or whatsoever. So I'm kinda willing to try that system first, but I need a micro ITX power supply. Should be fine. There are some that are pretty much a little PCB on the 24 connector pin, that we just go there and plug it in at 12 volt and it works. It does the conversions, everything should be fine, and they are cheap. So I think I'm gonna buy one of those things. And I have breakout boards for the parallel port already from my older machines. Should be fine. I'm just not sure if I'm gonna have enough, if that little board it's enough computing power for processing the steps, because with all the Mesa boards, it basically the FPGA chips, they are the ones that generate the pulses, which takes a lot of computing power from the CPU, from the main CPU, and it's kind of cheaper on a printer. You get the Raspberry Pi to do all the hard job, while the CPUs from the main boards, instead of computing everything like it was with Marlin, they just follow the rules. And that the Mesa boards are kind of the same thing. They have the FPGA processor in it, which process all the steps, and pretty much the system. It's a little bit on the contrary of the 3D printers if we think about it, but so it pretty much takes off the stress of the CPU of doing that. Yeah, I have a friend of mine that uses a laptop for that. So instead of a Raspberry Pi, he uses a laptop, just a laptop. He put Linux on it and a Clipper service on it, and it's the computer that makes the printer work. But yeah, but it's a laptop, it's not a desktop. Okay, so I have a few options to do. Because the Mesa board, it's kind of expensive. I know they are super good, and I'm pretty sure I'm gonna go with it one way or another, sooner or later. I'm just not sure if I'm gonna go straight with it, and I'm kind of scared because me and Linux, we never were good friends. I'm very good with Linux when I have all the copy-paste commands that I need to do, but other than that, I'm looking for info, so it should be fine. I see so many people using it. I'm sure I'm going to be able to do it. If not in 1 month, it's going to be in 2, but doesn't really matter. But yeah, so we have quite a few options on that front. The Mesa board that I intend to buy, it's gonna connect via network, so it's just an Ethernet cable connecting it. Should be fine. I've been doing some research because I want to do a CNC Pro like control panel. So I bought a 16-inch touchscreen for it, which it came in on the 24th. I haven't tried it yet because I don't have a cable to connect it to the Pi, since the screen takes a mini HDMI connector and the Pi takes a micro HDMI connector. I have HDMI to mini cables and I have HDMI to micro, but I don't have micro HDMI to mini HDMI. So we are good. My concern was I want to make a lot of buttons for the interface, like have physical buttons to like cycle start. Well, cycle start shouldn't be a problem because we have it should be a big button on the screen we can touch, but I would like to have a keyboard, a mouse, even that I do have a mouse, it's a touchpad, like a mouse touchpad, just in case of needing, or a trackball, something like that, because it's going to be touch anyway. So, but a numpad would be fine instead of pressing numbers on the screen. It would be nice to have actually a numeric pad. And I definitely want a feed potentiometer, so we can control the feed on a potentiometer and the rapids on a potentiometer as well. It would be very useful, or at least have buttons to reduce it or decrease it as we want. But ideally a potentiometer would be fine. Spindle speed, I'm not too concerned about being a potentiometer. Can be just a step up, step down. Should be fine, even probably on the screen. I don't mess a lot. Usually I don't mess a lot with the spindle speed, usually. But it's nice to have a quick way to, a physical button to do that. Coolant would be nice. I want to do a mist coolant, probably mist and air coolant, but mostly mist for aluminum and air just for plastics. What more? That would be important. Jog, I definitely need jog so at least 6 buttons for, no, not 6, 8 buttons for X, Y, Z and A, because I'm gonna put a 4-axis on this machine. So yes, so we're gonna need a bunch of inputs and outputs for, and LEDs and stuff for luminous illuminated buttons, something like that. And I saw someone did an amazing job using an Arduino to do all of that shit. Instead of using the Mesa card, he used an Arduino, just connect via USB, and everything is connected other than the holy sheet button. Everything is connected, LEDs. I'm gonna buy, actually that's something I'm gonna buy. It's not, you don't need a fancy one. I'm gonna buy, but if you're gonna use mist coolant, you're gonna need a compressor. I'm gonna buy one. I was looking something like this. That's what I intend to buy, because I actually want to buy a compressor for this shop. And I want something. Actually, I saw these ones from Vevor. I need to go to a local store which sells this kind of hardware, and they are a friend, so they do nice prices. But I'm looking something like, not this one, something like this. So 50 liters, so this is in Portuguese, but come on. Okay, send. So these are the ultra quiet ones, just because I have a big fancy capacitor compressor. And these ones are supposed to be super quiet. I've seen some reviews on YouTube, and the guy speaks on top of the compressor. The compressor, yes, It makes noise, but it's much quieter other than my big ass. I have a 200-liter one on my shop, and it's on outside of the shop, and still I heard it every time, even if I'm on the lathe or working on the CNC machine. And the CNC machine is going to be loud anyway, so these are oilless pump, ultra silent. Let me see if they say the kind of the dB. 58 dB, which is it's very low noise actually. Mine it's probably 85 or something like that. So yeah, I think I'm gonna go with one of these or something close to this. Exhaust volume, what's the, let me see if it says the, but yeah, I'm thinking something like this. That's what I intend to buy. And if with mist coolant, you don't waste a ton of air. It's just a buff that with a drop of oil every now and then, it's like every 3 seconds a drop of oil goes, and it creates kind of a mist. That's why it's called mist coolant. It's like fog. You're gonna set it at like 2 or 3 bars. So you should be fine. Anyway, so that's it for today. I hope you guys learned something or enjoyed the stream. We'll try to finish next time, so we're gonna mess with the wakeovers. So we finished the Y-stops, the ohmings, let's call it ohmings because it is what it is. So yeah, tomorrow we're gonna try. I think I'll be able to stream tomorrow. I'm not sure, but hopefully I can. So tomorrow we're gonna try to finish to deal with the wakeovers. It's only 3. I'm only concerned about, or more concerned about the Y. That's the worst one, and the Z, just the one on the bottom, not the one on the top. So let's try to figure that out. And then probably we want, if we can do that tomorrow or on the next stream, then we're gonna move to the enclosure. So I intend to do the default, the original enclosure. It's called Casa. I liked it, the style of it. I have no idea how the CNC machine goes attached inside. I haven't looked. I know there is an enclosure, and I really like. I need an enclosure. It's not like I need it. So yeah, we're gonna look into that. My main concern is, since I'm gonna use bigger motors, and the ball screws make the motors go a little more outside of the machine. My main concern is to see if the default size of the enclosure is enough to fit my modifications. So yeah, we're gonna take a look into that in a couple days. So that's it for now. Thank you guys for showing up. Thank you guys for making me company with this. Thank you for watching the stream. If you guys like the content, please like and subscribe. Doesn't hurt you. It doesn't really help me either so far, but hopefully one day. Yeah, that's it. Take care. I hope you guys had a nice Christmas, and see you guys next stream. Thank you very much. Good night, everyone, and see you next time. Bye bye.